Dear students, today we are discussing one theorem on that will be very useful for applying redundancy operations in various systems, reliability systems. Okay, I think you can see this file, and what we are trying to prove is regarding some inequalities on reliability function of coherent system. Okay, so let us consider h of p with the reliability function of the coherent system. Equal to h of p1, h of p2, etc. h of pn. Okay, so we are considering this reliability function of the coherent system. Now what we are interested to prove is h of p union p dash greater than or equal to h of p union h of p dash. So first result is h of p union p dash greater than or equal to h of p union h of p dash. This union is nothing but yeah. And second result is we can put a dash here. Dash means another probabilities, another set of probabilities. We can put bar here. So this is the first result we have to prove. And the second result is so this is we are trying to prove. Okay. So inequality will change. The second result. Okay, this we have to prove. And How can we prove this result? First of all, we shall compute this minus this one. Okay. What is this? This is exactly expectation of phi of x union y minus expectation of phi of x union expectation of phi of y, right? So what is this? This can be simplified again. This can be simplified as this expression can be taken outside. So right, by expectation of this is second step, that is the equal expectation of we have taken expectation outside, that is expectation of phi of x union y minus phi of x union phi of y. Okay, so I think we can replace this also. Bring this inside. Okay, so this is the second step. Again, you know that again we can simplify the right side. But you know that from the previous chapter, that is this difference. We have the result that this difference for a parallel system, this is actually greater than or equal to phi of x union phi of y for parallel system. So it is not necessary for parallel system. Equality for parallel system. So this is true for a coherent system. Okay. At the same time, equality holds for parallel system. We can substitute that, so this difference will be greater than or equal to 0. That means this is equivalent to say that this difference is greater than or equal to, so this difference is greater than or equal to 0, right? So when we substitute this value, you can easily claim that this is less than greater than or equal to 0. So that we can ensure that
ഇന്നത്തെ മാനേജർ ഞങ്ങളോട് തുടങ്ങുന്നു.
ശരി ശരി ഓക്കെ. So this is the result. Okay. So we can claim this one. Okay. Right. Before that, we can put one more step. Greater than or equal to 0, that is equal to say that h of p union p dash greater than or equal to h of p union h of p dash. Okay, so this is the first part of the theorem. Again we can prove similar result for p into p case. For that we consider have to prove വിപിൻ ഉണ്ടാവില്ല എന്ന് പറഞ്ഞിട്ടോ ഇനി തൊട്ട് കുറച്ച് പേരിലുള്ളൂ, കുഴപ്പമില്ല. ജനുവരിയിൽ നോക്കിയാൽ മതി, ജനുവരിയിലേക്ക് മതി. ഇനി this is equal to okay, this is the expression for h of p dash minus h of p into h of p dash, that equal to expectation of phi of x into xy minus expectation of phi of x into expectation of phi of y. Okay, now we can simplify. We can take expectation outside. So what will be the result? You can remove this term. This term also. Just take a simple bracket for these two functions. So similarly for the we have in the first chapter a result, that is phi of x into y less than or equal to phi of x into phi of y. മുക്കാലും തീർന്നേ കുറച്ചല്ലേ ഉള്ളൂ. ചായ ചാടിച്ചിട്ട് പോകാം. Vertical expectation of phi of x into y minus phi of x into phi of y. So we know that we have already proved the result of that. This is less than or equal to phi of x into phi of y. We have proved this result in the first chapter, in the redundancy section. So if it holds, we can easily say that so this implies what will be the next step? This difference. This difference is less than 0. Okay. So we can substitute in this equation, so that we will get this difference less than or equal to 0. Right. So automatically left side will be less than or equal to 0. So just keep the left side only. Less than or equal to 0. That implies this is less than or equal to right. So this is the result, the second result. H of p into p dash is an h of p into h of p dash. Okay. So when we obtain the equality in this equation, so let us denote it as equation number 2. Okay, when we obtain equality, when phi of x into y equal to phi of x into phi of y, then equality holds. Okay, that is possible only when the structure function is series. Okay, equality holds only if the structure function is series. In the previous case, equality holds only when this will become, this difference become, this is, that means in the previous case equality holds only if phi of x union y equal to phi of x union phi of y. That is possible only when system is parallel. So when system is parallel, the equality in this equation holds. Okay, when the system is in series, then the equality of this equation holds only because this difference phi of x into y will be equal to phi of x into phi of y. That is the reason, right? So that is the steps involved in computation of this theorem. and I will send to you this proof, and you can write. Okay, this is sufficient for today's discussion. And you write it and submit in the Moodle platform. Okay, if you have any doubt, you can ask to me. No problem. Okay, thank you.